radio transmitters and receivers in aviation introduction. Effective communication is vital in aviation, where the safety and efficiency of flight operations depend heavily on the ability to transmit and receive clear messages. This training module will delve into the principles of communication via radio waves, the configuration and use of radio panels and stacks in aircraft, and the specific functionalities of various communication systems, including the Garmin GMA 340, GTN 750, G530, and G430. Principles of radio communication. Communication in aviation is achieved by transmitting and receiving messages via radio waves. These electromagnetic waves carry information over long distances without the need for physical connections, making them ideal for aircraft communication. The basic components of this system include 1. Transmitter converts voice or data into radio waves and broadcasts them. 2. Receiver captures radio waves and converts them back into voice or data. 3. Antenna transmits and receives the radio waves. 4. Frequency. Specific bands of radio waves are allocated for aviation communication to avoid interference. Radio panel. The radio panel, typically located in the center console of the aircraft, is used to communicate with air traffic control, ATC, and other aircraft. It provides the interface for pilots to select frequencies, transmit messages, and receive communications. Key components of the radio systems include the frequency selector, push-to-talk, PTT, button, and volume controls. Radio stack configurations. As a crew member, you will encounter various radio configurations when assigned to different aircraft. We have outlined 2 common configurations, which generally include the following components. 1. Intercom. Allows communication between crew members and passengers. Allows the pilot to select which radio systems to use. 2. Radio COM1 and NAV1 are the primary communication systems for external communication and navigation. 3. Radio COM2 and NAV2 are the secondary backup communication and navigation systems and are used in case of failure of the primary radio system. 4. Autopilot. Automates flight control, enhancing safety and reducing pilot workload. 5. Transponders. Provide identification and altitude information to ATC radar systems. Intercom Garmin GMA 340. The intercom system is crucial for internal communication within the aircraft. It allows crew members to select which radio systems to use, 1 or 2, coordinate tasks, communicate with passengers, and ensure that all on board are informed and safe. 1. Volume rotary knob. Volume control. Adjust the volume for the pilot, co-pilot, and passenger headsets using the volume knobs on the front panel. There are separate knobs for the pilot and co-pilot, usually labelled pilot and co-pilot. 2. Squelch rotary knob. Manual squelch adjustment. If needed, manual squelch can be adjusted by pressing and holding the appropriate button, usually labelled SQ, and rotating the volume knob. 3. COM buttons. The COM1, COM2, and COM3. Buttons allow the pilot to select which radio to listen to. The COM1 mic, COM2 mic, and COM3 mic buttons allow the pilot to select which radio to talk on. Normally the COM3 and COM3 mic buttons are inactive unless the aircraft has 3 radio systems. An LED light on each button indicates if the selected button is on or off. 4. NAV1, NAV2, DME, and ADF buttons. These buttons are used by the pilot to confirm that the correct navigation frequency has been tuned in. 5. ICS buttons. Intercom modes, the GMA. 345 offers different intercom modes to manage communication between the pilot, co-pilot, and passengers. The modes can be selected using the intercom mode buttons. 1. All headsets are connected, allowing communication between the pilot, co-pilot, and passengers. 2. ISO, isolate button. The pilot is isolated from the intercom system and can only hear the radio. This mode is useful for handling ATC communications without distractions. 3. Crew button. Only the pilot and co-pilot can communicate with each other. Passengers can talk among themselves but not with the pilot or co-pilot. 6. Cabin audio buttons. This allows the pilot to communicate over the cabin's PA system. Radio systems. The Garmin GTN 750, G430 and G530 are advanced avionics systems that integrate communication, navigation and GPS functionalities into a single unit. This enhances situational awareness, flight management, flight planning, and real-time navigation updates. Garmin GTN 750. The Garmin GTN 750 is an advanced avionics system that combines multiple functionalities. Features. 1. Communication transmitter and receiver. Enables two-way communication with ATC and other aircraft. 2. Nav receiver. Receives signals from ground-based navigation stations. 3. GPS satellite receiver. Provides precise positioning GPS data. 4. Moving map. Display. Enhances situational awareness with real-time map data. 5. Flight planning. Allows for efficient route planning and management. 6. Touchscreen interface and rotary knobs and buttons used to select different menu options. Communication frequencies. Selecting frequencies using the Garmin GTN 750 involves a straightforward process facilitated by its intuitive touchscreen interface. Here are the steps to select frequencies. 1. Enter the desired frequency. 1. Tap the standby frequency display area. 2. A numeric keypad will appear on the screen. 3. Use the keypad to enter the desired frequency. Four. Tap the Enter button to set the frequency. 5. This will enter the new frequency into the standby queue. 2. Activate the frequency 1. After entering the desired frequency into the standby queue, you need to activate it. 2. You will have to swap the active and standby frequencies by tapping the active frequency box. 3. This will swap the standby frequency to the active position. 4. Verify the frequency. Ensure the selected frequency is displayed correctly in the active frequency window. Listen for any confirmation from ATC to verify the correct frequency is in use. 5. Emergency frequency. 1. You can activate the emergency 121.5 frequency by using the direct 121.5 MHz procedure. 2. This can be accomplished by pushing and holding the volume control button. 3. This will automatically tune in the emergency frequency 121.5 MHz. 4. Press this button in an emergency to immediately communicate on the distress frequency. 5. You can also manually enter in the emergency frequency as outlined in the previous steps. Garmin G530 and G430. The Garmin G530 and G430 radio functions and operations are similar to each other. Using the Garmin G530 and G430 radio involves several steps, including powering on the device, selecting frequencies, and managing communications. Garmin G530 and G430 features. 1. Communication transmitter and receiver, essential for ATC communication. 2. Nav receiver, supports navigation through ground-based signals. 3. GPS satellite receiver, provides accurate GPS position information. 4. Moving map, display, displays navigation and terrain data. 5. Flight planning, facilitates efficient route planning. 6. Menu options are selected via rotary knobs and push buttons. Power button, If the unit is not powered up, rotate the power volume knob located on the top left of the unit to turn on the G530. The display will light up and the startup screen will appear. Audio volume rotary knob. 1. Volume control. If needed, rotate the power volume knob to adjust the audio volume to a comfortable level. 2. Squelch adjustment. Pull the power volume knob out slightly and rotate it to adjust the squelch level. Turning the knob clockwise increases the squelch threshold, eliminating background noise. Selecting frequencies on the G530 and G430 radios. 1. Active and standby. Frequencies. A. The G530 and G430 allow you to manage 2 frequencies at a time. An active frequency for current communication and a standby frequency for quick activation. 2. To enter a standby frequency. A. Select the standby field. Use the large right knob to highlight the standby frequency field. Enter frequency. Use the large and small right knobs to set the desired standby frequency, TOTS. The large knob changes the MENS digits, and the small knob changes the KC digits. 3. To activate the standby frequency. A. Swap frequencies. Press the COM flip-flop button, usually labelled as C or with 2 arrows, to swap the standby frequency with the active frequency. The standby frequency will move to the active field and vice versa. Emergency frequency. 1. You can activate the emergency 121.5 frequency by using the direct 121.5 MHz procedure. 2. This can be accomplished by pushing and holding the volume control button. 3. This will automatically tune in the emergency frequency 121.5 MHz. 4. Press this button in an emergency to immediately communicate on the distress frequency. 5. You can also manually enter in the emergency frequency as outlined in the previous steps. Garmin Radio GTR 205. Using the Garmin GTR 205 radio involves a few basic steps, including powering on the device, selecting frequencies, and managing communications. Here's a detailed guide on how to use the Garmin GTR 205. Features. 1. Communication transmitter and receiver. Enables two-way communication with ATC and other aircraft. 2. Nav receiver. Receives signals from ground-based navigation stations. Selecting frequencies. 1. Power volume rotary knob, DORE. To turn on or off. Rotate the power volume knob to turn on or turn off the GTR 205. B. To change the volume, rotate the power volume rotary knob to adjust the audio volume to a comfortable level. 2. Adjusting squelch, .A. Manual squelch. Press the power volume rotary knob to access the squelch control feature. Rotate the squelch control knob to adjust the squelch level and eliminate background noise. 3. Select frequencies, DA, active and standby frequencies. The GTR 205 allows you to manage 2 frequencies at a time. An active frequency used for current communication. Standby frequency, ready for quick activation. B. To enter a standby frequency. 1. Select the standby field. Use the frequency transfer button, usually labelled with arrows, to highlight the standby frequency field. 2. Enter frequency. Rotate the large and small frequency knobs to set the desired standby frequency. 3. The large knob changes the MES digits and the small knob changes the KIX digits. Changing the standby field to the active position. To swap frequencies, press the frequency transfer button to swap the standby frequency with the active frequency. The standby frequency will move to the active field and vice versa. Emergency frequency. 1. You can activate the emergency 121.5 frequency by using the direct 121.5 MHz procedure. 2. This can be accomplished by pushing and holding the volume control button. 3. This will automatically tune in the emergency frequency 121.5 MHz. 4. Press this button in an emergency to immediately communicate on the distress frequency. 5. You can also manually enter in the emergency frequency as outlined in the previous steps. Communication protocol tips. Effective communication protocol is essential for clarity and safety in aviation. Here are some tips to help you communicate with ATC. It involves 1. Frequency. Be sure to enter the correct frequency into the radio. This ensures that communication is established with the intended air traffic controller. 2. Aviation headset. Equipped with a microphone and speakers for clear communication. Be sure the microphone is positioned close enough that you can speak clearly into it. Set the volume so you can comfortably hear what ATC is saying. 3. Push to talk. PTT. Button. Located on the yoke or a handheld mic, it is used to transmit messages. 1. Holding the button down will allow the pilot to transmit a message. 2. Releasing the button allows the receiver to listen to incoming messages. 3. Be sure not to hold the button down if you are expecting to hear something from ATC. 4. Otherwise, you'll be transmitting, unable to receive radio signals. 4. Radio systems. Ensure reliable transmission and reception of messages between the aircraft and ATC. Be sure the volume control is set at a comfortable level to hear ATC. Troubleshooting. If you are having trouble using the radio and communicating with air traffic control, use the following procedure to troubleshoot the radio system. 1. Check that your headset jacks are plugged in into the appropriate plug. 2. Check your headset volume. Be sure it is set loud enough for you to hear radio transmissions. 3. Check the radio volume levels if you experience issues with transmission or reception. 4. Double-check the frequencies that you have entered into the radio. 5. Check that the standby frequency has switched to the active position. 6. If you are using Radio 1, try switching to Radio 2. Configuring radio examples. The intercom allows the pilot to set up different radio configurations. We'll go through some examples of how to use the intercom to set up different configurations with Radio 1 and 2. Example 1. Intercom configuration using only Radio 1. 1. To receive and transmit radio messages on Radio 1 with Radio 2, silent. 2. Select the COM1 and COM1 mic. Buttons to the on position as indicated by the button's LED light. 3. Be sure the COM2 and COM2 mic buttons are off. This is indicated by the LED lights on COM2 and COM2 mic. The lights on those buttons should be extinguished. 4. You can now transmit and receive messages on Radio 1. 5. Enter the frequency on Radio 1 into the standby queue. Then switch it to the active position. 6. Press the yoke mic button to transmit your message to air traffic control, ATC. 7. Release the yoke mic button to listen to or receive radio messages from ATC. 8. Be sure to release the yoke mic button, otherwise you will be in transmitting mode, unable to hear any communications from ATC. Example 2. Intercom configuration using only Radio 2. 1. To receive and transmit radio messages on Radio 2 with Radio 1, silent. 2. Select the COM2 and COM2 mic. Buttons to the on position as indicated by the button's LED light. 3. Be sure the COM1 and COM1 mic buttons are off. This is indicated by the LED lights on COM1 and COM1 mic. The lights on those buttons should be extinguished. 4. You can now transmit and receive messages on Radio 2. 5. Then follow the same steps as illustrated in Example 1, Steps 5 to 8. Example 3. Intercom configuration using Radio 1 while listening to Radio 2. 1. To receive and transmit radio messages on Radio 1 while monitoring or listening to Radio 2. 2. Select the COM1, mic, buttons to the on position as indicated by the button's LED light. 3. Then select the COM2 button to the on position. The COM2 mic button should automatically be in the off position. Verify this by checking the LED lights. 4. You can now transmit and receive messages on Radio 1 while listening to Radio 2. 5. Then follow the same steps as illustrated in Example 1 to transmit and receive messages. Steps 5 to 8. Conclusion. This concludes our module on radio communications. By following these steps, you can effectively use the Garmin radio packages to manage communications. Effective communication is the backbone of safe and efficient aviation operations. The integration of advanced radio systems, intercoms, autopilots, and transponders ensures that pilots can communicate clearly with ATC, other aircraft, and within the cockpit. Understanding the principles and functionalities of these systems is crucial for any pilot or aviation professional. Thank you for watching our video. Please subscribe to our channel, click that like button, and let us know what you think about the video. Did you like it? How can we improve it?